Proving congruence, angle, side. The angle, side theorem. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding side of another triangle, then the two triangles are congruent. Here's the theorem in action. Given that angle A is congruent to angle P, angle B is congruent to angle R, and AC equals PQ, prove that the triangles are congruent. Alright, so we begin with our given information. We see that AC is congruent to PQ, therefore the triangles are congruent due to the angle, side theorem. Angle, side. Here's our angle, side proof. We are given that angle A is congruent to angle P and angle B is congruent to angle R. Also, side AC here is congruent to side PQ here. Prove that the triangles are congruent. Alright, so we begin with our given information about the angles. Therefore, the triangles are similar because there's two pairs of congruent angles. So the AAS similarity theorem. Alright, we were also given that segment AC is congruent to segment PQ, which means that they're equal. That's the definition of congruent segments. It's also an arithmetic fact that you can then divide both sides by PQ and get AC over PQ equals 1. Now we can set up this ratio here because of the definition of similar triangles. AB here over PR equals BC over RQ, which equals 1. And when you rearrange that, you see AB over PR equals 1 means that AB equals PR, and same for here, BC equals RQ. That's also an arithmetic fact. Therefore, the segments are congruent, and making all three sides having congruent corresponding sides, that means that due to side triangle congruence, these triangles are congruent. ASA and AAS triangle congruence. Another way of looking at these two theorems is that once you show that two angles in two triangles are congruent, then you know that the third angles are congruent, so the two triangles are similar. That means that the triangles have the same shape. If you can show that a side in one of those triangles is congruent to the corresponding side of the other, then you know that they're the same size. Thus, the scale factor K equals 1. If the triangles are the same size and shape, they're congruent. It's really just a formality whether you use the term angle side angle or angle side, since all three angles must be congruent. However, to note the difference, if the angles are both adjacent to the side which has been shown to be congruent, then the reason for congruence is angle side angle. If not, then the reason is angle side. So here we have an angle that's congruent to this angle, we have this angle congruent to this angle, and this side congruent to this side. This is angle side angle. Over here we have angle, which is congruent to this angle is congruent to this angle, and then this side is congruent to this side. This is angle side. Proof strategies. Number 1, indicate congruent parts in the diagram. So angle H is congruent to angle C. So H and C. Alright, then we choose a different color. Angle HTA, so this angle here, is congruent to angle CTA here. Prove that the triangles are congruent. Alright, so we have indicated which angles are congruent with which. Number 2, we have two pairs of congruent angles. We need a pair of sides. So, can you see any sides that are congruent? This side right here. This is a shared side of the two triangles, and it's congruent with itself due to the reflexive property of congruence. Therefore, these two triangles are congruent to one another because of angle side theorem. Here is a two-column proof puzzle. Given these two sets of congruent angles and this line segment being congruent to this line segment, prove that the two triangles here and here are congruent. Alright, so we begin with our given information about the angles. Therefore, due to the common angle theorem, we know that, here I'll draw it out, angle FLH, this angle here, is congruent to angle JLG, this angle here. All right, and we were also given some more information. FG here is congruent to HJ there. Therefore, FG is congruent to HJ, that's given. Therefore, FH is congruent to JG. So from here to here is congruent from here to here due to the common segment theorem. In conclusion, the two triangles are congruent because of angle-angle side congruence.